All right. 4.5 was the worksheet, and you said
Number 6.
6.
Hey.
Ooh, number 6. Okay. Okay. So geometry time. Is there anything that you could decipher just by looking at the picture, like reflexive property, parallel lines?
Parallel lines.
Really? It has indicated?
Yeah.
Not by looking at the givens, just by looking at the picture.
Yeah, it's parallel lines.
Not by looking at the givens, just by looking at the pictures.
J
I do not see any arrows pointing that there's parallel lines yet. It's part of the givens, I bet you.
J
All right, so this is number 6. So we know that NK is parallel to ML. NK is parallel to ML. All right. If I know that, is that enough to conclude alternate interior, exterior, same side interior, anything like that?
Yeah. Wait, no?
Corresponding? Corresponding?
Yeah.
Corresponding I'll go with. So, okay, this is given. So I know that this has to go with this because there's corresponding angles. So, and notice I haven't written all the givens down, right? So sometimes we don't want to write them out. So that's number 1, number 2. But you can say that J and K is congruent, bless you, to angle NML because of corresponding angles. Totally. Okay, why did I not go and write all my givens down right away? Why?
So you can write your first given and then write.
Yeah, there's a progression of thoughts that could take place. Yes, you could list all your givens, which is great, but sometimes you might miss something out. So right now, I have an angle and I have parallel sides. Yeah.
Does it help us in any way to have like a lot of things,
Sometimes. A lot of things written down?
like help us like point wise, get more points for.
No, because I'm going to try and do it in the minimum amount, and I might be able to do it in 5. If you show me 4, I have to go through your thoughts going, okay, kind of. Like there was a couple on the last test, it was like a 10 point. A lot of people got 8 out of 10. I forgot the reflexive property. They had everything else right. And it's like, you forgot the reflexive property. So, all right, number 3. This is going to be another given, I think. So then we know that JK is parallel to NL. So JK and NL. Now, does that mean they're congruent? Does that mean they're congruent? No. But I might know, so I have corresponding there. I have corresponding here as well. Do you agree? Because if this line is parallel to this line, and that's my transversal, those are corresponding angles. So step number 3, this is given. Number 4, we can go ahead and say that I know that angle KJN is congruent to angle, so KJN and L and M. And again, those are corresponding angles. Now I have angle. So maybe I can get an angle side. Maybe I can get an angle side angle. Maybe. I still don't have all the givens written down, do I? One last one I could probably put for the givens. N is the midpoint of JM, and that's a given. So N is the midpoint of this. So that's going to allow me to go ahead and state that JN is congruent to NM because of Y. Yeah, definition of midpoint. Okay, so I know this and this are congruent. Do I have enough information to prove those two triangles are congruent now? Yeah, why? Angle, side, angle. So I can go ahead and list, and I don't know what the order they have them in, JKN is congruent to J. NLM. 7 angle setting. So sometimes it's wise to put all the givens down right away. Sometimes it's wise to put the first given, see if you can make a conclusion out of it. Put the next given, see if you can make a conclusion off of that, and keep going. That's how I would have went through this problem. Could this one be done shorter? I think, well, I don't know what they said in the back. They probably did it in one step. Yeah. Number 5, okay, yeah. Number 5, number 7. Okay, I'll do 5 first and then 7. Is that cool? Number 5. Angle 4, angle 3, angle 2, angle 1, C, B, A, and D. Is there anything sticking out up there right away that we might start thinking could be useful? How much? Vertical angles. Okay, so like 1 and 2 and 3 and 4 are congruent. Maybe. I like that. Vertical angles might work. Okay.
Alternate exterior.
Alternate exterior. I don't know if any of the givens I've looked at yet, so I don't know what's parallel to what.
Okay.
I would agree that there are indeed alternate exterior angles. I just don't know if I have parallel lines to conclude they're congruent. But I think you're right. So I haven't even looked at the givens. I was just looking at the picture. Yeah. Supplementary.
Linear pair.
Linear pair. Oh, so like angle 4 and angle BA. I don't really have. I don't have a label. You're absolutely right. That is a linear pair. I would have alternate interior angles as long as these are parallel lines, they can be congruent. I do have AC congruent to itself. I have a reflexive property I can go with. But I don't know. Well, let's just see what we can do. So, givens, we have angle 1 is congruent to angle 4. So angle 1 is congruent to angle 4. That's a given. And now I want to not go with the rest of that. I know that I can state that angle 3 is congruent to angle 4, and I can say that angle 2 is congruent to angle 1. And the reason I can say that is because what Don said, I think it was Don, so with the vertical, right? Okay. So that means here to here, and here to here. And then that's going to go ahead and allow me to state that angle 2 is congruent to angle 3. And that's kind of a substitution scenario. Okay. I still have another given I haven't put yet. Oh. 5, we say that AB is congruent to CD. That's a given. So AB is congruent to CD. Cool. Okay. I think my reflexive property might work here. Number 6, I have segment AC is congruent to itself. There we go. Can I prove the two triangles are congruent?
Yeah.
Yeah.
Side.
Not angle side side.
Side angle side.
Side angle side. Yep. So side angle side is going to allow us to say that. And I don't know. They say triangle ABC or whatever order they put it in. ABC and CDA. Okay. Side angle side. So again, does it work for you in your mind to start? Take a look at the diagram first, saying, "Gosh, what are some things I might be able to conclude?" Okay, let's look at our first given. Is there any conclusion? Maybe. I don't know. Yeah.
Just to clarify, why do you list the reflexive property in here?
Because it's a great question. It's a silly one to list, but because it's a shared side, and this is why. Another way to start looking at these proofs is to break the triangles apart.
Oh, I just do them separately?
Mm-hmm.
Okay.
So that's another way to look at it, and then you know that that and that are congruent. That would be why I'd say to list it, because then you can list it separate, even though you'd have A, C listed twice. That's why I would think that's where we should go with it. Does that make sense?
Yeah.
Cool. And sometimes breaking it apart might be good for you. Yeah.
So if you're doing a proof and there's like a shared side, you always use the reflexive property.
I would always think, okay, it should be there for me. Now, if I list it and I don't need it, it's okay. But sometimes it starts clarifying the problem. 7? Is that what's that?
Yeah.
Okay. If I could draw a straight line, I'd be a pretty good guy. But I'm not a good guy. I'm just some village idiot that's here for you all.
You're not good. You're great.
Dude, love you. All right. Again, not looking at anything else other than the diagram. Is there something that is shared between the two big triangles, SPR? The bottom. So SR is congruent to SR. It might be something reflexive for us. It might be. I don't know yet, though. Okay. So that's about all I can conclude off of this right now is knowing, oh, I might have a reflexive property to worry about. But let's start working out, see what we can get. Step 1, we have QSR. Okay, so angle QSR, so this angle is congruent to this angle. Is that okay? So I know I have angle, side, or side, angle, side. Bless you. I might, at this point, say, you know what, I'm going to go ahead and list the reflexive property. Okay, was it the right one to list right away? I don't know. Reflexive. So again, let me just draw this. Let's just take it apart. Q. So I know that angle QSR, so this angle is congruent to this angle, and then I have this here. Okay, so I've just taken it apart for you. Yes, the SR is the exact same on both. Might be better to see it that way if you take it apart. So now I have an angle and a side, so I can have angle, side, or side, or perhaps angles. Well, that's not going to work, but I might have angle, side if I can prove another angle. I don't know yet. So I have a given, still I haven't put, so number 7. I know that angle PSQ is congruent to angle QRP. That's a QR and a P if I could draw again. I'm a little tired today. You guys tired?
Yeah.
Oh man,
We should have.
We like sleep.
Like sleep? Yeah. Let's see. PSQ. Okay, so PSQ. This one looks a little easier to see when I take it apart, does it not? Because if I go and mark it here and here, it's kind of hard to decipher what the heck's going on. But if I take the two apart, notice that. Doesn't this look like it's hard to recognize what's taking place? You have an angle and an angle like that. But if you take it apart, it's quite obvious. Why are these triangles congruent?
angle, side, angle.
Yeah.
What in the world?
Yeah.
Got it.
I'm there for you.
Got it. Like a blue.
And that is the old angle, side, angle. So again, what are some things that we're putting up here that might help us along? Well, we might slowly go through, we might look at the diagram first, recognize that there might be some properties we might do. We might want to break the diagram up a little bit. I think in this case, it makes complete sense to break that diagram up. Yo.
Isn't it angle PSQ? Wait. No.
So angle PSR is that the bigger the angle.
So you added the angles together?
No, I didn't add any angles together. So what helped me on this one is I recognize that I have two triangles that are sharing a side, so then I broke it into two. So this double angle here is right here. And this double angle here is right here, because I split it apart. But notice, this is the same as this. It's the same line. And there's where that reflexive property will kick in. So sometimes if we take it apart, it might start making sense. Especially if you have some goofy, overlapping song and dance. I'm just trying to give you guys and girls some clues of what might make it easier to go through. And this might be one thing. Does it work for you? Maybe. If it doesn't, then don't do it. Yeah. 8? Yeah. Number 8. Okay, so I'm just going to draw my diagram up. V, Y, Z, X, W, 1, 4. Okay, just looking at the diagram, not looking at anything else. We might have some overlapping triangles that we're trying to prove congruent. Do you agree? Okay, I don't know what they're going to tell us yet. Let's see, they have VWZ. Yep. So they have VWZ. So let me just draw this up here real quick. And then the other one is XW, thank you, XWY. Okay, so we did have them overlapping, but I'm showing that this is what we're going to try and prove. I think if we do this way, we won't have the goofy, silly stuff. Like, we'll use this as our main thing, but then we can start marking off below. All right, they tell us angle 1 is congruent to angle 4. That's given. Angle 1 is congruent to angle 4. Does that really help me prove anything yet? I know they're outside angles, so I might be able to prove like linear pairs congruence, but we're not there yet. Let's see if this helps us a little bit more. Then I know that VW is congruent to XW. So VW is congruent to XW. So let's mark it here, VW, XW. Does that make sense so far? Yeah.
So since 1 and 4 are congruent, and you need angle V and angle 1 to be supplementary, couldn't angle V be congruent to angle X?
Maybe. I wasn't seeing that right away. I agree with you. I wanted to see if this would present itself a little better, but you might be totally right going, there's a supplementary angle, there's a supplementary, I think you're totally right. It might help us, it might be where we have to lead, but I'm not sure yet. Okay, so that's why I didn't jump to it right away to create a 16-step proof like I'm notorious to do. Okay, but I think your thought process is correct if that is where your mind's going. But I just wanted to hold off on that for a moment.
Yeah.
Cool. I'm going to put my other given. I know that Vy is congruent to XZ. That's given. Vy, so this little segment here is congruent to this little segment here.
How do you show that on the separate triangle?
That's where I'm confused. Because like right now, I kind of just know kind of like this type of thing, right? Okay. I'm going to show this though. This is kind of where this and this are, correct? Of course, you can't see the difference between red and green. You don't, they look the same. But I think that I'm going to call out the reflexive property. YZ is congruent to YZ. It is indeed reflexive. And then there are things that I could do. I can go the longer route, which I think is easier for some of you to see. I'm going to go ahead and say that Vy plus Yz is equal to Vz. And then step 6, I'm going to say that Xz plus Yz is equal to Xy. Is that okay? And that's just segment addition postulate. But I didn't prove congruence at this point. So now that I know I think this right here, I could plug in right here. What do you think? So step 7, I'm just going to do it once. I'm going to go ahead and say that Xz plus Yz is equal to Vz, and that's substitution. So notice what I did. I saw this. I subbed it in here. Now, are these two things part of it the same for 6 and 7? Notice Xz, Xz, Yz, Yz equals Xy equals Bz. What can I say about here and here? They're congruent. Why are they congruent? Because I used the transitive property. Is what I did. Okay, so now xy here is congruent to Vz here. Now I think that linear pair is going to work. Okay, I wanted to stay away from it for a moment, but I think I can say it now. Okay? So let's see what we can do here. So angle 1 plus, and then number 10 is angle 4 plus. You can say both of those. WVY that's a VY plus angle 4 WZX. They're both equal to 180 degrees. Why can we say that? What kind of pair? Linear pair? I'd go with supplementary as well. Either one would be totally fine with me. Okay. Being those are both equal to 180, can I say this? And why? Transitive. Right, transitive. Good. So this one's taking longer, I'm sorry. Do we know angle 1 is congruent to angle 4? It's one of our givens. Yes. So that means that if I extend my page, I'm going to plug in for this. I'm going to say angle 4 plus angle WVY is equal to angle 4 plus angle WZX. That's substitution. Holy shnikes. Step 13, angle WVY is congruent to angle WZX because of subtraction. Now I know those angles are congruent, so now I know this is congruent to this, which is this is congruent to this. So can I prove the two triangles are congruent? And if so, why? Side angle side. So step 14, holy moly, 14, side angle side. So triangle is congruent to triangle. I don't know what they were labeled as, sorry. Holy moly.
28.3.
Why? I like it. It's so much cool thought. If you say so, math too, dork. All right. Make sure your name's on your assignment. Pass her on in, please. Yeah. Yeah. Go. Prove an angles and sides congruent using CPCTC. Develop an understanding of how to prove two angles or two sides are congruent by first proving two triangles are congruent. Okay? So we're going to use something called CPCTC. May I move on? If triangle ADC is congruent to triangle MPQ, what are 6 pairs of congruency statements we can state? Well, we can say that angle A is congruent to angle M. Agree? Angle D is congruent to angle. And angle C is congruent to angle. This is P and this is Q. So I've just proven those. Why can I say that? Because congruent parts of congruent triangles are congruent. Or CPCTC. Okay? What are some other things I can say? I can say that segment AD is congruent to segment MP. I can say segment DC is congruent to PQ. Notice the order of the letters. And then I can say that segment AC is congruent to segment MQ. And again, I can state all this because CPCTC. I've proven two triangles are congruent. If I've done that, then all the matching parts of those triangles are congruent to each other, meaning the angles and the segments. Okay? Voila. Next stuff. Are these two triangles congruent, and how do you know? Side angle side. Okay? So these are definitely side angle side because I have a side, an angle, and a side, and a side, an angle, and a side. Yes, one's tilted from the other, but still understand that the single tick goes with the single tick, the double tick goes with the double tick, the single curve goes with the single curve as far as the angle goes. So this is side angle side on each one of these triangles. I could then go through and state all the other things are congruent. I could say that segment CB is congruent to segment TS. I could say that angle B is congruent to angle S. I could say angle C is congruent to angle T. Because I've proven by side angle side that these triangles are congruent. Yeah?
On the test, how many proofs are there going to be?
I don't know. I haven't seen it yet.
How many proofs are going to be in life? A lot.
All right, may I move on?
What is the test again?
I don't know.
You don't know?
No.
Isn't that
Oh, we have a quiz on Friday, I guess.
You don't even know what time.
So one time, this period, Friday.
Do you know what's on?
Proofs.
How many?
Yes.
A lot.
Only
Sure.
proofs?
Johnny, you only get one proof, but you have to do it in 299 steps.
Okay.
Everyone else has like 3 proofs.
That is
All right.
Wait, we only 3 proofs?
I have no idea. What are 3 pairs of congruent angles? So I could state this angle goes with this angle. I could say that this angle goes with this angle. They're different. Okay? What are sides I could say? I could say this can go with this. If 2 triangles are congruent, are there other parts that must be also congruent? Yes. Everything about one congruent triangle is congruent to every part of another triangle that happens to be congruent. It happens over and over. It's not just by accident. We would always be able to write additional congruency statements if we knew triangles are congruent. So, if I have 2 triangles up there and then I say, hey, I want to know that this segment and this segment are congruent to each other, you have to prove the 2 triangles are congruent first in order to make that conclusion. So we have enough power. If blank,
2 triangles are proven to be congruent.
2 triangles are proven to be congruent, then the corresponding parts
Those triangles are congruent.
parts of those congruent triangles are congruent. Seem okay?
Yeah.
Uh-oh. Here's, oh,
Are you sure about that?
wrong thing. And we say CPCTC. Yeah. Hot dog. All right. Not really looking at the stuff. It looks like I could probably break this apart. I'm going to put what we're going to prove. We want to prove that CD. Whoa, time, no, stop. I want to make these highlighted. No, make a highlighter. I want to prove that CD is congruent to CB.
I got you.
We good? So there's some things that we should recognize looking at it. It looks like I have two different reflexive properties. Do I need them both? I don't know.
Alternate
Both
interior
down.
angles. No, they're not parallel. You don't know that. What are you
We
talking
don't know
about?
parallel. Good. I like it. So let's start putting our givens. Angle 1 is congruent to angle 2. Mark it. We good?
We have to mark it on the test?
Well, I'm just so we have it. Given. All right. I know that number 2, angle 3 is congruent to angle 4. Given. That and that. So
Oh, you could do the reflexive for C.
it's for C, the whole thing, right?
Yep.
Cool. So I know that CA is congruent to CA. That is reflexive. So this right here is congruent to itself. Do I have enough to prove that the triangle on top is congruent to the triangle on bottom?
Yeah.
Angle side
Am I
angle.
ignoring this one? Yes.
Angle side angle.
And then
So we have triangle CDA is congruent to triangle
CB.
CBA because of angle side angle. So my last thing to prove is this.
CPCTC.
CD is congruent to CB. And we could say because of CPCTC. Done. Corresponding parts of congruent triangles are
Congruent.
Yeah. We good? Can I move on? Quit flipping the bottles.
What CPCTC
Look,
stands
he has a
for?
ball.
Corresponding parts of congruent triangles are congruent.
We both got it wrong.
All right. This one, just looking at my diagram, and we might have to pull it apart. We might. I don't know though. We might be able to keep it together. I would say we can say that MQ is congruent to MQ reflexive. That might work, but I don't know yet. So let's start listing some of our givens. I got given. So angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. Oh boy, that's not going to help us much. So we could do supplementary. So I like it. Let's do this.
Could you say the triangle MNQ is congruent to?
Not yet. But we're going to get there.
No?
So angle 3 plus angle 5 is equal to 180. 4 angle 4 plus angle 6 equals 180. Linear pair or supplementary, right?
Come on.
We good so far? That's going to allow us to do this. Did I say that? And if we know that, we know I could take this and start subbing it in, so perhaps I'll put right here. Is that okay? So I'm going to change out angle 4, make it angle 3. So step 6, I'm going to say that angle 3 plus angle 6, so I'm putting it right there, is equal to angle 3 plus angle 5. Is that okay? I did it kind of out of order. All right, oops, so shoot. 6, that's substitution. Then angle 6 is congruent to angle 5. Subtraction. So angle 6 and angle 5 are congruent to each other. Angle 6 and angle 5 are congruent. Angle 6 and angle 5. I gotta say MQ. Oh yeah, oh this is good. Check it out, check it out, check it out. This triangle here and this triangle here. Is there a shared side?
Yes, the base.
Yeah, baby. MQ, right?
Let's go.
LETSGO.
Let's go rodeo.
MQ.
You, baby.
Are we done yet? Almost? Please? Triangle. Yellow. It's congruent to triangle pink. Because of angle side.
Nice.
Oh yeah.
Right? That then gives me NM is congruent to PQ.
Oh no, I have to put this back in.
Oh shoot.
Because
CPCTC.
is that in the way too much? Where are we at?
There's like 3 more.
Oh, we had that proof. Okay, we're okay. You got that? Okay. Got that? Let's have you guys work on that. And then, what's tomorrow? Thursday. So we got to review. So why don't we will finish these notes tomorrow, and then we'll make sure we get all of 4.6 done. But I would say, can you get a halfway done on 4.6 tonight? Cool? Yeah. You guys are awesome.
I'm probably gonna come tomorrow during force to do the